okay, you'll need to go to Google Classroom, okay, and you'll see that I've posted the new assignment in here, graphing position versus time lapse. Hopefully you've already joined the Google Classroom. If not, you'll have to do that. I don't know why you've waited so long, but you kind of need it, okay? So you'll go into the classwork tab here. You'll see the graphing position versus time lab. You'll click on that. There are a lot of documents in there, and there will be more to come, okay? For right now, what we have are the smart cart instructions, which is what I'm going to go over. That's basically how you connect it to your phone and allow your phone to collect the data from the motion for you. Okay, there'll be some instructions on graphing, which is basically how to transfer the data over and then make a graph in Google Sheets, which hopefully you all already know how to do. And then there will be a PDF, which is just the lab sheet. Okay, that's what I'll be working off of. It's your reference. And then the first thing that's in there, furthest down, is your lab report. Okay, whenever we do a lab, I build the template for you. All you have to do is click on that, and it will open it up. You need to fill it in. Okay, I've already put in the bones. You have to put on the meat. Okay, so you'll have the problem, which of course you'll restate in your own words in the form of a question. Okay, you'll identify your manipulated, responding, and controlled variables and explain them. Okay, and it's same as grade 10. Okay, identify the manipulated variable, explain responding variable, explain 3 controlled variables with explanations for each. Okay, those explanations should include things like why they are the variable you've selected and what you're doing with them. Okay, so for the manipulated variable, this is the manipulated variable because it's being changed or whatever in this way. This is the responding variable because in the experiment it's going to do this and be measured this way. Okay, and then your 3 controlled variables. This is a controlled variable because it can affect the experiment in this way. Thus, it is being kept at whatever, okay, or how you're going to control it, or whatever you need to say, how you're controlling it, and what effect it would have if it was not controlled. Okay? So that's what you need for the design part. Okay, for your hypothesis, if, and then statement, I'll go over that in a few minutes as well. Okay, then you'll have your materials. You don't need to do anything with that. That's what we're using. Okay, you'll have your procedure. You just need to follow it. You'll put your data in here where it says data. Okay, so that will include your chart as well as your graphs. Okay, that's where they will go. Okay, and then for the analysis, you'll have your position versus time graph in the data. Okay, and you will be determining the velocity of both cars using y equals mx plus b, which nicely Google Sheets will spit out for you. Okay, all you'll have to do is manipulate it. I'll go over that as well. Okay. Then you'll have your conclusion, where you'll copy and paste your hypothesis and then give me an explanation as to why you can accept it or reject it based on your analysis and your data. And then for your evaluation, 2 sources of error, how they affected the experiment, and what you could do to improve them in the future. All right, those are the expectations for the lab report. Now remember, with your sources of error, they have to be errors within the procedure, not your ability to follow it, right? You cannot list human error as a source of error, right? Because here's what that says to me. Mr. Coderre, I screwed up. I know I screwed up. It messed up my data, but I used it anyway, and I did the rest of the report, so my whole report is now meaningless. Please take marks off, okay? You don't want that to be the last thing I read in your procedure. Okay, it would basically be like saying, yeah, Coderre, we forgot to measure the position of the cart, even though it's a position versus time lab, and that really affected our data. Yes, I imagine it did. Okay, so human error is not a source of error. List things that are kind of within the experiment that you really couldn't do much about. Okay, basically environmental things. Okay, a good place to look for sources of error is in your controlled variables. Were you truly able to control that variable like you said you were? If not, that's a source of error. Okay, everybody follow on that? All right, so the experiment that we're going to be doing, okay, is going to run like this. Okay, we are looking to determine or calculate the speeds of 2 different science carts. We used to use toy carts, now we use these science carts because they're better. Okay, so in the design here, okay, are manipulated, responding, controlled variables. So here's how the experiment will work. You are going to have these carts. All right, they're brand new. You are the first class to use them. they are over $600. Please treat them accordingly. It's like you're holding on to a gold bar, okay? Except that if you drop a gold bar, it's still a gold bar, and it's still worth money. This isn't, okay? If you drop this, it's worthless. And I'll be very angry. And I hear the thumping sound, and the ambulance sound. I don't know what I put on. So, don't want that, okay? Yeah. All right, be careful with these. Now, all we're going to do is simply put them on the track, okay, once they're connected to your phone, which I'll show you how to do in a minute, okay, and we're just going to give them a very small push. Right, now, when I give them a push, what is the cart going to do?
Move.
Okay, in what way?
Forward.
What kind of motion?
Constant.
Acceleration.
It's going to accelerate first, but this lab is about something traveling at a constant velocity, so it's only going to accelerate while I'm pushing it. Right? As soon as it's off my fingers, it should be traveling essentially at a constant velocity. In reality, it's actually doing what? Slowing down a little bit, right? But it'll be small enough that we won't really notice it at that point. So you're just going to give it, like, and this is what I mean by a small push, like literally this much. Okay? You just have to tap it. Okay? Just a tiny little tap to get it moving. Okay? The slower it goes, the better, because then it sends more data before it runs out of track. Okay? You're going to do that twice. So the first time, give it a very, very small push. The second time, give it a slightly larger, but still very small push, so that it travels at a slightly different velocity the second time. Right? What we don't want is two identical graphs. Okay? Everybody follow me on that? Okay. So that's what we're doing. So we're measuring the following things: time and position. And that's it. Okay? Those are the only two things that we're measuring in this lab. Right? I want you to think about how this lab is going to work in terms of the variables. Okay? The longer I allow this cart to go, the farther it will go. Agreed? Okay. So in that way, I'm kind of determining the length of the experiment. Right? The experiment can really only run as long as I have space for it to run. So I've kind of determined where the experiment begins and where it ends, which means I'm manipulating the length of the experiment, or time. You're welcome. If you were paying attention, you got that. If you weren't paying attention, watch the podcast later. Okay. It means I'm also measuring the position of the cart. But as I just said, how far the cart travels, or the position of the cart, depends on how long it has to travel, which means it's kind of responding to how long I allow it to travel for. Not everybody got that, but that's okay. Things that need to be controlled are anything that can affect the speed of the cart, because we want the cart to travel at constant velocity. So would that mean that velocity is a controlled variable? Yes. It is. We want it to stay the same. Otherwise, this experiment just doesn't work. Okay? You need to come up with two more controlled variables. Anything that can affect the speed or velocity of the cart needs to be controlled. Think about the nature of the track, okay, and things like that. Anything to do with that track can determine or alter the speed of this cart. So those things would need to be controlled. Okay, for our hypothesis. Okay. Now, I was saying to you earlier, a hypothesis is a statement containing the words if and then. The if part of a hypothesis talks about the premise of the experiment, or the relationship between the manipulated variable and the responding variable. Okay? The and part of the hypothesis talks about the experiment. It just describes it briefly. In this case, it could be a cart is allowed to travel at a constant velocity while position and time are recorded. It could be like that simple. Okay? The then part talks about what you're going to get in terms of results. So it predicts the results, okay? And talks about what you can do with those. All right? So what kind of relationship are position and time going to have for this situation?
The more time you give it, the farther we'll go.
Okay, and so what kind of relationship is that? Starts with L. Okay, linear, exactly. So in the if part, that's probably something you'll want to talk about. If there's a linear relationship, blah, 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 okay, and the part's allowed to do this. Then, in the then part, okay, so, sorry, I'll write this down. Okay. Okay, the then part we'll need to talk about how you will calculate the velocity of the cart using your position versus time graph. We have done that lots of times already, and we've talked about it lots already too. You should be able to figure out how you get velocity from a position to time graph. That's what the then part will be about. Okay, questions so far? Right. Pretty much given you most of this, so you should have it all there. Okay? Is it a good idea to watch this when you're putting your lab report together?
Yeah.
Yes. Just quickly watch it again, scrub through it to the parts you need. Okay, but it does, I do give you quite a bit, and you don't want to lose marks and stuff I gave you. I do, but you'll have to give me one minute here now. Okay? All right. So let's look at how we hook this stuff up. Okay, so how do we hook up this cart to our phone? Okay, so the first thing you're going to do is you're going to open the SparkView app on your phone. Okay, so you hopefully downloaded that and you now have it on your phone. Okay, when you do that, okay, you should see something like this. Okay, so you'll open the SparkView app and you'll choose to use sensor data. Okay, you're not going to actually do this till you have a specific cart to use, but I'm going to walk you through it so you can kind of see. Okay, when you do that, it will then ask you, what sensors do you want to use? It will even use the ones on your phone. You don't want that. Okay, your phone is not going to be traveling along the track. It's going to be completely useless. Okay, people do this all the time. They select the onboard sensors, and you know what their data looks like? Somebody holding a phone perfectly still, because that's what it's reading. We want it to read what the cart's doing.
Do we want to let it access our camera?
You don't need it to access your camera, no.
Right.
Yeah, you're not taking any pictures. All right, so what will come up, okay, when you've got that open, I'll turn this on, okay, what will come up are any available smart carts. Each smart cart has a serial number. Okay, it's in this little silver box. Whichever one you have, that's the one you want to select. Okay, so right now, probably 295826 blue is showing up. Okay, that's this one. That one's probably showing up on your phone right now if it's in range. Okay, so you'll select that. Okay, that'll select that device. And don't worry, when we're actually doing the lab, if you're having trouble, I'll come around and help you. Okay. This thing has many different sensors in it. We only want some of them actually sending and recording data. Otherwise, you get this big, huge spreadsheet full of data you don't need. Okay? So, all we want to have for this experiment is position. Okay? That's the only thing you would need to select, because we're only doing a position versus time graph for this experiment. So you can uncheck everything else. Okay? You could even uncheck the force sensor and all that stuff. We don't need it. Okay? We just need position checked, and that's it. Okay? So you'll do that, and then you'll hit graph, and it'll pull up on your screen a graph with a, I'll look like this. Okay? You'll get this screen with a start button on it. Okay? That's, you press that, and it starts recording data. Right? So what you'll do is you'll put the cart on the track, okay, hit start, your partner gives it a little push, and you'll see the graph start to build right on the screen. Okay? Once it's traveled to the end of the track, you stop it, you press this will turn red and say stop, okay? Press it, and then set it at the start of the track again to try run 2, where you push it a little harder. Okay? Do exactly the same thing. It'll plot a second graph, and you'll now have 2 sets of data. Right? Then you'll export it to Google Drive, and you'll be off. Okay? So it actually shouldn't take all that long to collect the data we need. I'm going to stop explaining there because I've already explained so much you probably won't remember it all. Okay? Once we have the data, then I'll walk through exporting it and using it in Google Sheets and all of that kind of stuff. Okay? So I have 4 tracks. We weren't able to get the other tracks ready for today, so we only have 4 tracks. One really long one against the back wall, and there are 3 on the table here, and there are 4 carts. Okay, so yes, we're going to be in very big groups, and that's okay. It actually doesn't take that long to collect the data. You just need to have people in your group that you're sharing your data with. Okay? So if you can get into groups of like 6, okay, grab a track and a cart. Do what I showed you, which is push the cart twice, okay, get the data, and then we'll talk about what to do with the data after that. Now guys, make sure that you're doing this with the tracks on the floor. And don't let the cart go off the end of the track. It'll damage the suspension, so please don't do that. Okay, so just find a spot on the floor somewhere and get this set up. All right, so what you're going to do when whoever it is has the data, has shared it with you, it's going to show up as a CSV. Okay, when you try to open it, it'll just look like this. Okay, so if I just click on what he originally shared with me, okay, it won't show me this. Okay, it won't show me the open with Excel. It'll just have a thing here that looks like the Google Drive symbol. If you click on that, add it to your drive. Once you've done that and you open it from wherever you put it, then it will give you the option to open with Excel. Why it's not doing that right away, I don't know, but that's the way it's doing it now. So when you get the message that someone has shared something with you, click on it. It'll look like this, except there'll be a little symbol right here that says add to my drive. Okay, if you put your cursor over, it'll say add to my drive. Put it there, close it, open it from wherever you saved it, and then it'll look like this, and it'll say open with Excel 2006, or no, I don't want to open with Excel, sorry. I want to open with Sheets. Never mind, it's still not working. All right. So once it has been shared with you, okay, what you need to do is go to your drive, okay, to wherever you saved it. Okay, I saved it in like this rabbit hole of folders. In here, okay, and it shows up like this. It says, well, Easton Dorm, because that's who sent it. Okay, if I click on that, why is it still I had it. Okay, so once you have Google Sheets open, okay, click File, Open, and then open that file with Google Sheets, and then it should work.
I'm gonna get
So,
doxxed. I'm gonna get doxxed, Mr. Coder.
Yeah.
He's gonna dox me.
Okay, and so if it says spreadsheets up here, just X out of that, it'll show you this. Okay, if I click on that. Okay, Easton, when you did that.
So we all have our own.
But we have 166.
Okay, so you have all this crap that you don't need. Okay, and there's a lot of it. That's okay. All right, we're going to get rid of most of it. Like, for example, I don't need the date and time.
Me neither.
All right, so I'm just going to delete. I'm going to delete that whole column. Okay, I'm just going to get rid of it. Okay, I'm going to keep the time for run 2 because it was my slower of the 2 runs, which means it'll have a longer time interval. Okay, so I'm going to keep it. I'm also going to keep the position for run 2. I'm going to get rid of velocity and acceleration. I don't need any of those. So I'm actually just going to highlight all of these things that I don't need. Okay, including the time for run 2. I'm going to get rid of that. I'm going to get rid of velocity, get rid of acceleration. I don't need any of that stuff. Okay?
We don't need the time.
Oh, wait, you copied this over.
Yeah, no, those are the same thing.
Okay, where's your run? Where's run 4?
It's to the right. Yeah.
So
Why
we
do
just
you think the
basically
times
delete
are the
velocity
same?
and
Because it's
acceleration
time.
for everything.
Okay, so we're deleting, okay, guys, all of this stuff that we don't need.
Then you can just click the row.
Oh, you can click the row?
Yeah, you just click, you hold control down and you can click all this other stuff.
Wait, don't you need it?
No, I'm not gonna need any of that stuff.
You only need time for the first.
I only need time for the first one, yeah. Okay. Now I'm gonna move this column over.
We don't need velocity.
No, we just need position.
I don't use it though.
Why won't it let me move this?
Discord.
Okay, so what I want to finish with is this. I want to have the time for whatever run was your longest one, okay? Your position for that run beside it, and then the position for your second run. You'll see that because the second run was faster, it doesn't take as long. Okay?
Yep.
All right, now, I want to build a graph, but to do that, I need to get rid of this run 2, run 4 stuff up top. Okay, so I'm just going to put in here position, okay, run 1. Okay, and then I'm going to do the same thing here. And then, okay guys, if I'm explaining something, I need you paying attention. If you do this wrong, I will be merciless when I mark.
Bro,
Just so you know.
why are you highlighting it?
Okay, so I'm going to delete this row here, okay. This is the data that I now want to graph. So I'm going to highlight all of it. Okay, so just click and drag. Okay, I'm going to highlight it all. And then I'm going to click Insert. All right, and I'm going to hit Chart. Once you do that, okay, you're going to get something like this, which it actually did a decent job of, except I don't want a line chart. Okay, I want a scatter plot, which means I have to scroll down here to scatter. Okay, so you can see I get 2 patterns pretty much like I should. I've got, you know, a fairly linear form here. It really starts to kind of flatten off past 2 seconds, so I might actually delete that data. Okay, but this one's pretty nice. Okay, it's pretty straight all the way along, which is exactly what I wanted. All right, so now that I've got that graph, okay, I can add a few things to it, which is what I'm supposed to do here. So I'm just going to go into Customize. Okay, and this is where I can label the axes and put in a title, right? So I'm just, instead of going with the position M run 1, I'm just going to say Graphing Lab position versus time graph.
Stop inserting.
How do you do this?
Okay. Then I'm going to click on horizontal axis title. Actually, I don't have to. It actually did put time down here for the horizontal axis. Okay, I am going to put the vertical axis title in. Okay, that'll be position in meters. All right, and now my graph looks pretty much like it should. Okay, I'm going to go to series. Okay, and I'm going to put in a trend line. Okay, so if you click on series, because this will draw our best fit line for us. Okay, so I'm going to click trend line. Right. When I click trend line, it says linear, okay, and all that kind of stuff. Then I want to put in for my label. This is where I get the equation, where I get y equals mx plus b. So I click here on label, and I go use equation, and you can see that it put it here. Okay, so this is m. This 0.143 is m times x plus, and this number is b. right? So it spit out the equation for each line for you, which saves you a ton of work. Okay, you don't have to actually find all that stuff on your own. All right, now that I've got that, okay, I can put my legend somewhere else if I want to. Okay, I usually put it on the right-hand side, so it makes more sense over there. But that's up to you guys.
We're all on different
Move your box to the right.
What are we going? Are we going to sleep?
Okay, now guys, couple of things here. You may need to doctor your data slightly. Here's what I mean by that. Clearly, this graph curves off at the end, which means the object was doing what? It was starting to slow down. I don't want that. I only want the part of the graph where it traveled at a constant velocity, which it did fairly well until about, let's say, 1.5 seconds. Okay, so what I'm going to do is I'm going to go back to my data here, and I'm going to delete all the position data after 1.5 seconds. Right? That will automatically update in my graph. And now I get a much more linear looking graph, which is what I want. And it actually changes, my graphing equation as well. So now the graph looks the way I want it to look, and now I can do my analysis. Okay, but that's what you need to do in order to get your graph built. Okay, I'm sorry that took so long. Okay, but now you just build your graph and you calculate your velocity from your graph. Hargan, question?
So where do you want us to delete it?
Well, it'll be different for everybody's data. Like, if your data doesn't do what this data did, like, I don't have to modify the data for run 2 at all. It's perfect. It's a nice straight line. But this one definitely got flatter, and I don't want that part. So I just took it off where I thought it started to get flat. Okay, if you need help, put up your hand, I'll come around and give you a hand. All right, so once you have your graph built, okay, and you've got the equations, whether you have them up top or you have them on the right-hand side, doesn't matter, okay? It's that equation, or those equations, that you're going to need to do the analysis, which is saying, calculate the velocity of each cart using the equation. So what I want you to do, okay, is I want you to understand that this is really saying that y equals 0.177 times x. Right, so I'm just going to copy this over here so I can show you what I mean. Okay, so you have this graph. Okay, what this is really saying here is that for the blue one, y equals 0.177 times x plus 0.0104. Okay, it's spit out the equation for that line. Okay, what you have to remember is, okay, what does every part of this represent? Okay, remember that the equation normally looks like this: m times x plus b. So this number is b, this number is m. Y and x are any values on the line. Okay, so what we're looking for here is you need to show this equation manipulated so it solves for velocity. Okay, whichever part of this equation solves for velocity, I want it manipulated for that. You do not need to plug in numbers for y or x. I just want to see the equation manipulated for velocity. Okay, so you keep y and x in there if you don't need to add anything. Okay, so manipulated for velocity, and that's it. Just give me an explanation as to why that represents velocity. So you'll have two equations manipulated for what you think represents velocity, and explain why. Okay, that's all you have to do for the analysis. Then you've got your conclusion, you restate the hypothesis, explain why you accept or reject it, okay, and then your sources of error.
Oh, what does this do?
I believe I made this due for a week from today, but I'll double check. The due date is in Google Classroom.
Yeah, I know.
Give us edit out.
I don't know how.
Give us that information so I can
Okay, due September 16th, so I did make it due Monday, a week from today. Okay, so you got lots of time to come in and see me and schedule help or at lunch if you got questions or anything like that.
But click the share.